Hi and welcome to yet another video in the RHCSA video series. Today's video is on containers, getting started. So we're going to talk a bit about what containers are, and then we're going to do some basic management of containers using an application called Podman, which is essentially for managing pods, but pods are like multiple containers. So it's just a matter of managing those. So the idea is that a container is a extrapolated operating system. So you've got the OS at another layer. So you have the OS running across in the back end, basically. So you have a common OS, be it redhat, whatever, and then you have the container on top of that. So say if you want a HTTPD server, you wouldn't build a new redhat server, you wouldn't then install HTTPD, then configure it and all that sort of stuff. You can have pre-canned images that have all of this pre-configured. So you'd use a container, so you'd use something like Podman, or in most common cases people use things like Docker, and Docker and Podman have lots of images that allow us to say, I want to spin up a HTTP instance. I'll pull that image down and I will run it as a container on my system. So what we'll do is it will run it as in the background as a container, and that would actually function as a full HTTPD server, and it utilizes your backend operating system to actually run it. So you could have obviously multiple different types of containers, but a common thing we see is we have like these fairly beefy systems that run run Docker or Podman, pretty much the same thing really, and they allow us to then run multiple containers on that same system. So we could have 10 instances of HTTPD running, and say if we lose one of those crashes for whatever reason, we've then got another 9 that can continue going. And also with all the orchestration within containerization, you can also say one particular node is crashed, so let's delete that node or container and let's spin up a brand new one. And you can do that completely on the fly without any human interaction. So it means that you're a lot more highly available in that way as well. Another benefit is potentially with security as well, because you could standardize your container and give it just only the access it requires. So perhaps it's a HTTP server, so it needs port 80 and 443 access in it, and you can actually completely shut down SSH to the container. So that the whole of the HTTP base can be completely locked down, and the only way to access it is you create a new image or a new container, a new image for the container, which you then spin up to make the changes within that container. So say HTTPD has been updated and you want to update it, so you update it in the offline image you've got of it. You create do all the little changes, save that image, then pull that image down into your Docker repository, and then replace one by one your current containers with this new image, and it obviously creates new containers. Hope that makes sense. So I'll try to put some graphics on the screen as well that kind of explain it, but I'll also link in the description for some more details if that was a bit unclear in that particular section. So what we'll do is we'll run through some stuff around Podman, and I guess it also make more sense as we're going along. Exactly I can kind of explain as we go along what we're doing and how it's all working. So it kind of explains itself better when we do that. So the first thing will be to do is install Podman. In most cases that won't be installed already, so we're just going to do, as always, just do a sudo bash. So people that have used Docker before we'll actually find that Podman pretty much has the same CLI. So that's certainly a benefit for a lot of people that have played with Docker before. Certainly I have. So that kind of helped me pick up Podman pretty rapidly, to be honest. It's all pretty much the same thing. It's nothing major in there, thankfully. So let's let it do its installation stuff. So yeah, in just case you missed that as well, so it's just DNF install Podman, and it installs quite a few packages. Okay, so that's installed. So all we've done so far is install Podman. So Podman has a pretty comprehensive help. I think you can just do Podman help, and it will list almost pretty much all the commands that are available here. But we'll go through some of these, of course. Not all of these are going to be immediately relevant, because there's lots of you can go pretty complex with containers, as you can imagine. So first thing to do is let's do a Podman search, and let's search for HTTPD. So as a good example, as I mentioned previously, so Podman search HTTPD. Okay, so that's displaying pretty badly, but okay. So if I go back up to the top, it kind of make it a bit more clear. So we've got index, name, description, which is this, stars. So stars is how many people have essentially liked it. Is it official? And is there any automation there? So let's go here and have a look for something other than 0. There's no stars on a lot of these, so they're probably not the greatest ones. There's actually one here, look, and it's from the Docker library, so it's probably a good shout. It's just a Apache HTTP server project, so I think that looks like a pretty good one. This one's got quite a high number as well. Some have got 9 and stuff, but this is 3,191, so it's probably the best one. So we pull the full name here. So docker.io is the library it's coming from, or index. So just we can ignore that part. It's the second part we need. So it's just this name here. So docker.io/library/httpd. So just copy that, and I'll just do a clear to bring this up to the top. We just do a Podman pull to pull it down, and we just give it the full name, and just press enter. And you can see it's copying all the relevant files, and pretty much that's it done. So it's as quick as that. So we now have everything we require to create a very, very basic HTTPD instance. So if we do Podman images, we can see on the repository, this one, which we just did, got the tag latest at the moment, with the image ID is currently this, when it last created, so it's quite up to date, and the size of the image. So obviously new images will be created, as I mentioned earlier, and then we would have to incorporate those into our containers once we're happy they're working. Right, so how do we actually run a container? So we just do is actually Podman run, and we can just give it the name of the repository. So if you noticed, I'm getting lots of messages directly into the log. So what it's doing is running directly into the command line. So this is in an attached mode, which is what you don't really want in most cases, to be honest. So it's running the container directly on the system, and it's taking away your prompt. So what I can do is terminate this. So we just do Podman, Podman PS. So there's no currently containers running. So PS is processes. So we just do clear again. So we're going to do another Podman run. Okay. This time we're going to do -d and then T to give us a terminal if we need to go into it. But we will, so -d for detached, -t for the terminal, or TTY. And let's do some port forwarding. So -P 8080 to 80/TCP. So what's happening here is if someone connects on port 80 to our system, it's 8080 on the system is going to redirect it to port 80. So it allows us to do some network address translation. So again, if you're running multiple different HTTP servers and different services on the same system, you may have different ports going to different things, that sort of thing. So you can do it this way. So we'll just do this and then we'll give it the name. So we're going to run it with detached mode with a terminal if we need it, -P to do the port forwarding 8080 to port 80 TCP. And we get all this number here. So that's basically the container ID that's running. So if we just do a Podman PS, we now have a container. So we do PS -A, we get a bit more information. So we can actually see the ones that have actually been killed off earlier. So you can see that's my original one. So this one, PS, will just show us what's currently running, and then PS -A will show us the stuff that's also been exited. So we've got some exited ones here. So we can see that's been up 19 seconds. So if I rerun that PS command, it's been up for 45 seconds now. So let's test this out. So if we do a Podman PS again, just make sure it's running. It looks very happy. So if we connect on basically localhost port 8080, we should be able to get to it. So we can try from this machine here, local on the machine. Okay, so in my Firefox window, I'm just going to type 127.0.0.1 and then 8080. And we've got an "it works" message. So that's a very, very good sign that that's working. We can actually confirm that's really is what we're seeing here. So we flick back to the terminal and we can just do a Podman and then stop. And to specify which one we want to stop, we actually can just give the name. So it's a short name here, but we've also got the long name. You can actually specify the long name as well. So that was when we first run it, we'll give that full name there. We'll just give the short name here. So I'll give it a few seconds. It's now stopped. Let's just do a Podman PS. We now have nothing running. Just flick back, refresh the page, and unable to connect. So that was definitely running from that pod. So cool. Let's do that again. Let's rerun that again. So we can have 8082. So what I'm doing now is just repeating the command for different ports. And now if we do a Podman PS, you now see we have a lot of containers. And I've given different ports because obviously they have to be different. As you can see in here, that message there is saying you cannot bind to test address already in use, which makes sense because you can't port forward to something that's already using that port. So if I do refresh this now, that should work. I also should be able to go to 8081, 8082, 8083, 4. Oh, 4 I don't think I did I? Hopefully I didn't, otherwise it's broken. Yeah, 883 is the last one I did, so that's all good. Okay, so if I clear the screen now, we can also do a Podman logs. So if I do Podman PS, let's get a name of container ID first, and we can just do a Podman logs. So these are all the logs from this. So Podman logs, and we can see couldn't determine the fully qualified domain name. That's fine because that is because I don't have DNS in this particular environment. That's absolutely fine. Resume normal operations for Apache, no worries. And we've got the command line has been run. This is just command line for Apache. And we can see the gets. So that's actually us getting the, you can also use these random names it generates. So some people may use those to reference the pods, the containers. So if we do you can do the same thing with that. So that's just a random name it creates. So Busy Heisenberg just brings me back to Breaking Bad. Perhaps not so much pods, but that's great. So let's do a Podman top. So top, as I covered in previous videos, is the processes. So we can have a look at what's running on there. So you can see not much, and also it's very light, and there's not really that much running on the system at all. So it's good to see it's very light and efficient, and as you can see, we can just kill one off and bring it back up. So if something was broken in that port 8081, I can stop it, then start a new one up, and we're good. So we can do it. So if we do a Podman stop, and we do Busy Heisenberg. So we can do that. So we can do a start and stop. So potentially you could have, we're going to cover that in the future, where we have that start and stop as part of service scheduling. So system CTL will start and stop that as part of the system. So you could have that again. You could have a Docker, a Podman run as part of the system startup. So you could have HTTPD startup as part of this, for example. So start and stop just literally starts and stops the pod. So if we do, let's do stop again, and we just do a Podman PS. We can see that there's only 3 running now. If we do a PS minus A, we can see it was exited 8 seconds ago, so that's the one I just exited. So let's just do a Podman start again. And for example, we really want to get rid of this particular container, and we want to delete it. So let's do a Podman remove and give it its name again. It's running, so that's a good point. Yep, it should stop that. Podman stop. 2 minutes to stop and start, so I forgot which one I'm on. Podman stop, and then we do Podman RM. So that's been removed, and if we do a Podman PS, we can see that we've only got those 3 running. Podman PS minus A. So if we do a Podman PS minus A after removing that, we can now see the one that was running on 8082, which was the Heisenberg entry, has been completely removed. So that's all cleaned up and removed from our PS minus A. That's pretty much all I wanted to cover within the Podman section. Again, this has a manual page. It's just a container engine. Yep, CLI comparable. Yes, basically easy to transition between the two. I'm going to do more advanced features as we progress through this mini course. As part of it's going to be as covered in the RHCSA as of 1st of October. So basically right now it's going to be an exam, so make sure you cover this if you haven't already. I hope this let's do an info on Podman as well. So yeah, a bit more info as well on the command. So that's pretty much it. Thanks for viewing my video. As always, can you hit the like button if you've enjoyed this video, hit subscribe if you haven't already, hit the bell icon for notifications of when I do release new videos. As you've noticed already, I've popped on the screen the usual stuff. So I've got the Ko-fi page for any donations. If you are kind enough to donate to me, that would be awesome. Also, I've popped my TeePublic page for any merchandise, if that's something you're interested in. and finally my Discord server URL information, and you can use that to ask more detailed questions that if you can't ask on YouTube itself. So you're more than welcome to check it out. Thank you.